This segment finishes our course overview with a brief summary of the course modules and topics. The course includes one or more of the following modules, each encompassing several subtopics. And note, by the way, that some modules may not be included in your particular database course. For instance, if you're taking this course for a general SQL background, we may not include a relational algebra module. The first module is the one that you're hearing right now, and that's Overview of Databases. There's a bit more to go, though. After this lecture, we'll wrap up the overview with a discussion of why it's worth studying databases and why a database management system, a DBMS, is more than just glorified file storage. The next module, Basic SQL, will cover the most fundamental SQL concepts. When you're done with it, you'll be able to do basic queries on existing databases, and it includes these topics. First, we'll look at the relational data model, the structure of database tables, rows, and columns, and the use of keys to link tables together. We'll show how broadly this simple structure can be used to represent different types of data, and we'll briefly discuss the ER, or entity relationship diagrams, that are used to represent relationships between tables. And we'll discuss setting up a database server so that you can try out the SQL commands in the following lectures. Then, once we understand the basics of tables, we'll look at the SQL select statement used to retrieve data from database tables. We'll start with selects on single tables, including where, order by, and other clauses in select statements. Exercises will involve performing single table select statements of varying complexity on one or more example databases. And then we'll extend to selects that join multiple tables together, working across sets of tables. Joining tables, or relations to use the abstract term, is perhaps the single most powerful concept in SQL. And exercises for this topic will involve performing multi-table select statements of varying complexity on one or two example databases. Now, our next module covers the data definition language, DDL, and data modification language, DML, subsets of SQL, which let you create databases from scratch and modify existing database contents. And it includes these topics. First, creating and filling databases. Having seen how to use existing databases, we'll look at the SQL, or technically the data definition language, or DDL, to create tables and to define column types, keys, and foreign keys, constraints, etc. We'll also look at the insert statement for adding new rows to tables, and we'll look at the complexities of column types, including nullable columns, date types, and so forth. We'll also look at the SQL, technically data manipulation language, or DML, for changing database content and for altering the structure of existing database tables. Exercises will ask you to mimic the evolution of a website database through several versions, which is a realistic use of DML in industry. The module after that, SQL functions and aggregation, introduces SQL functions for working with column data like dates and strings. It also introduces functions for computing statistics on column data, and introduces the grouping feature of SQL statements that lets you do statistical and other sorts of aggregate data analysis. The module topics here are going to be simple SQL functions, where we'll look at various SQL functions that work on single columns or groups of columns within the same table row, doing mathematical, string, or date operations. And then aggregate SQL functions, and that will cover functions that let you compute maxima, sums, etc. of groups of rows. And we'll cover select clause, group by, and having that let you define row groups to be summed, averaged, or otherwise computed in aggregate. Exercises will ask you to do select statements using these clauses and SQL functions. The module after that involves designing databases. Having gone over a full range of SQL, DDL, and DML, we'll take a look at designing databases, including an informal discussion of normalization, a process of removing redundancies from database tables, and a discussion of indexes used to speed operations on columns whose data is the frequent subject of searches in select statements. Exercises will require that you take a single unstructured file of data, build a database of several tables from it with a limit on the total number of columns of such tables, and then perform select statements on your database that operate within a limited time. The next module, Advanced SQL, will cover two very powerful SQL concepts, subqueries and outer joins. But they let you do much more sophisticated and creative queries against a database. Exercises for this section will have the most sophisticated select statements of the course, with a good number of subqueries and outer joins. And the specific module topics are subqueries, using the results of one select query as a subunit of another permits much more powerful database queries. And in this topic, we'll explain the various ways to do that. And then outer joins. A special form of SQL join operation involves joins between rows of different database tables, even if the rows do not actually exist. These outer joins, like subqueries, provide much more powerful database analysis. Module after that, database programming, explores the fact that SQL is only one way to access and modify a database. Many programming languages supply libraries that allow a program to interact with the database server to perform queries, make modifications, and even to create databases from scratch. Also, most database servers provide a SQL-based programming language of their own, by which you can program database operations that run directly on the server. In the JDBC topic, we'll show how to write Java code that addresses databases via the JDBC standard, a set of classes and interfaces for performing database operations from Java. Exercises will involve writing Java JDBC code for some database purpose. And then a topic on stored procedures will cover small programs that comprise a sequence of SQL and DML statements and are stored in the database itself to be performed by the database server directly on database content instead of by some client program. Exercises will involve revising JDBC code to use a stored procedure instead, and comparing the speed and convenience of the two methods. A module on transactions follows. A database server often performs many different operations at the same time. Multiple people may frame queries at the same time, or more commonly, software like a web server may programmatically make many different requests simultaneously, often on the same content within the database. Database servers provide transaction management, a means by which simultaneous operations on the database can be prevented from interfering with one another. And this module will cover transaction management and the various isolation levels it provides to prevent different simultaneous database accesses or modifications from interfering with each other. And then finally, relational algebra. Having covered the SQL implementation of relational algebra, we'll then look at the mathematical representation of concepts like tables, selection of columns, where clauses, and the like. And we'll convert these SQL concepts to a more concise notation and perform algebra-like actions on the expressions that result. Exercises may ask you to simplify relational algebra expressions or to determine the equivalence or non-equivalence of different relational algebra expressions.